Hello students, today we are going to discuss electrostatics charge distribution concept. This is a very small concept, required basic concept. Using this we have a lot of problems can be solved in the coming topics. So what is charge distribution? Already in the previous classes we discussed about whenever you taken any body, the charges will be distributed on the charged body. So that charges whatever it is distributed on the charger body that will be accumulated on the charger body on the surface of the charger body. This is the thing we discussed in the previous. Whenever you taken any charger body, the charges will be accumulated on the surface of the charger body as you're looking like this. Right now these charges will be occupied according to the type of shape of the body. If the particles are distributed along the length, the charges will be distributed only along the length. If the body having area, more surface area, the charges will be distributed on the area. And if the body having volume, the charges will be distributed on the volume, because there is atom, there is a charge. So here the charge distribution basing on the atom distribution. So atoms can be distributed linearly, one, and aerially and volume wise. So here, if you want to understand this one, you consider one of the thin wire of negligible area of cross section. If you given a charges to this one, the charges will be accumulated on this one as you're looking like this. In this case, the charges which are distributed on this one we are calling as linear charge distribution, one dimension. That is nothing but linear. That means along the length, if the charges are distributed, that is called linear charge distribution. Now, if you taken the second one is one of the square plate, like this is a square plate, like if you taken. Now, if the square plate is taken, if you charge this body, then what happens? The charges will be accumulated over the surface of the body, that is, which contains the surface area. It may not contain surface area, but across the area, the charges will be distributed. That is nothing but called as aerial charge distribution. And third one, some bodies may have volume. Example, if you take a sphere, solid sphere, if you taken, in the case of solid sphere, the atom will be throughout the body, the atoms will be there, so the charges will be accumulated across the total volume of the body. This type of distribution is called as volume distribution. In the case of halo sphere, if we taken halo sphere, halo means there is no atoms present at the center, only outer boundaries only we are having the particles, that atoms. That's why charges will be accumulate only on the surface. It is similar like football. So whenever you charge that to football type bodies, in this case the charges will be accumulate on the surface of the body. So according to the way, sometimes the charges will be distributed linearly, sometimes the charges will be distributed aerially, sometimes the charges will be distributed volume wise. So now we are going to discuss in this what is linear charge density distribution, what is aerial charge distribution, what is volume charge distribution, and formula based will derive. After that we will go for problems on this. Now first one, linear charge distribution. Linear charge distribution we are indicating with the letter lambda, where the particles are distributed only along the length. There is no area, there is no volume contained by that body. That means we are compared to length, the area and volumes are negligible in that case. Example, you take a wire, already we discussed, we take a wire. This wire contains the length is L. Now what we are doing is we are giving the charges to this. The charges which are given to this one is accumulated on this surface of this wire. The particles which are on the wire are maybe infinite, maybe finite. According to the condition of the finite infinite, we can able to understand. So if one charge is, if you say small q, the total charge of the wire which is accumulated is capital Q. So total length of the wire is L, and here the charges are distributed according to linear charge distribution called as lambda. What is lambda? We can define the lambda can be defined as it is the charge accumulated per unit length, is called as linear charge distribution. How many charges are accumulated per unit length? This is the total length if you taken, this is the charge if you taken. How much charge is present per unit length compared to total charge? That charge per unit length is called as linear charge distribution. From this you can able to calculate the total charge of the body, that is Q is equal to linear charge density into length of that. Using this one we can able to calculate this. So here what is the lambda units? The lambda units is equal to charge we are measuring in terms of coulombs by length is meter. Simply we can write as coulomb meter minus 1, because this is important in the case of competitive examinations or general understanding of concepts of this. Dimension formulas also they can able to ask. The next one is areal charge distribution. The areal charge distribution we are indicating with the letter sigma. So here consider one of the hollow sphere, or otherwise you take a square plate. Both are contains area. The sphere contains the surface area. It is not having volume. Hollow sphere. This is the plate which contains only area. So in this case, whenever you given the charges to this one, the charges will be accumulate on the surface across the area of the body. So this type of distribution of the charges we are calling as areal charge distribution. In the case of square plate also, the charges will be accumulated throughout the area as a areal charge distribution. This areal charge distribution we are indicating with the letter sigma. So A is the area or S is the surface area if we taken. In this case, I can write sigma is equal to nothing but called as areal charge distribution is equal to, okay, the charge accumulated, the total charge of the body, if you say as Q in the both the cases, the charge accumulated per unit area is called as areal charge distribution. Also, we can write in terms of, in the case of hollow sphere, surface area, because sometimes the body may not have area, it may have surface areas. In that case, you can use this formula. So according to this one, the sigma units we can write as charge we are measuring in terms of, okay, that is coulombs, and area we are measuring in terms of meter square. So if you write the units of this one, coulomb meter minus 2 is the unit we can write according to the condition of this. So this type of distribution is called as what? That is called as areal charge distribution. So if you want to write the formula for this, okay, particularly for the case of sphere, the sphere having radius r, the sphere having radius r. So in this case, I can write the Q by S I can write. In this case, that is Q by S is nothing but surface area. So the surface area of this sphere is equal to 4 pi r square is the formula for that you have to know before. So from this, what is the total charge of the body means? In the case of sphere, how much charge is distributed on the complete hollow sphere when it is charged is equal to Q is equal to, I can write as sigma into 4 pi r square I can write. So using this one concept we can able to get it. The sigma is called as areal charge distribution. This areal charge distribution, nothing but, this is nothing but areal charge density we can also call areal charge density. This density is always constant and 4 pi is also constant. If you taken the constant condition, the charge accumulated on the body is directly proportional to square of the radius of the sphere. So this is one of the relation we can get it. That means if we taken the more size radius sphere, the more charges will be accumulated, less charges will be accumulated on that one. This is one of the, which one? Areal charge distribution. The volume charge distribution we are indicating with rho. This is the distribution where the body is having volume. You take a cubes contains volume, you take solid spheres contain volume. So some sphere like a cone, solid cone if you taken, it is having volume. So whenever you taken the certain volume bodies, that means where the particles are distributed along the volume, in that cases if you given the charges to that, what happens, the charges will be accumulated over the complete throughout the volume of the body. That type of distribution of charge is called volume charge distribution. So here I can take the example of one of the solid sphere. Whenever you taken the solid sphere of radius, certain radius r, if you given a charge to this one, the charges will be, we are writing throughout the body here. That means because the atoms are present inside also and on the surface also, that's why we are writing the charge distribution throughout the body. But in the case of, if you see this one here, there is empty. Okay, in the case of aerial distribution, there is empty space. We are not drawn any charges inside that. Here we are draw the charges in complete area. So this is having volume, right? And charges are distributed. The total charge of the body is Q. Now we can write, we can define the rho. Rho is called as what? Volume charge distribution. The volume charge distribution is equal to, this is the charge accumulated per unit volume, is called as volume charge distribution. In the case of this sphere, I can write that volume charge distribution like this. Rho is equal to Q by, what is the volume of the sphere? The sphere contains radius, the sphere having radius. So that the volume of the sphere we can write in terms of radius as 4 by 3 pi r cube. We have to know before. So from this I can write the total charge on the body, okay, which case in the case of volume charge density case, the total charge on this volume of the body is equal to, I can write as rho into 4 by 3 into pi r cube. So this is the total charge on the surface of the body which contains the volume, where the volume distribution of the charge takes place. Where rho is called constant, if we say, in the case of some cases, it may be most of the cases we are taking as constant. In the case of higher advanced level, some problems will be there which are variable, okay, density also is there. Here, constant charge density, that's why it is rho is constant, 4 by 3 also, 4 by 3 pi also constant. So from this I can write the charge distribution in the case of volume charge distribution is directly proportional to cube of the radius. So here the volume charge density unit, what I can write, Q is nothing but, what is the Q? Coulombs. We are measuring volume nothing but meter cube. So I can write coulomb meter minus 3. This is the unit of this one. So these are the points important, and based on this one, we'll go for some example problems now. Now we will have a problem on this based on distribution of charge. You can see the question based on integration method. In the competitive exams, this type of model questions asked in the previous competitive examination. So look at this one. A point charge Q is situated at a distance d, small d, from the one end of the non-conducting rod of length here. So here I taken one of the non-conducting rod of length, how much here? From this, at a distance of small d, we kept a charge Q. That means we taken a charge here, I am taking here, that is capital Q, which is a distance of d from one end of the non-conducting. That means this is the first end I am saying, this is the second if you say, from this end, this charge is arranged from this. Now, this is the carrying, that means what is it now, the non-conducting rod of length L carrying a charge Q. That means this rod, whatever you take in the length L, it is carrying a small charge Q. Total charge is small. This is the way they given in the question also, so you can see the diagram of that. Now, the force experienced by Q charge means this is one of the charged body. So whenever it is charged, what happens? The charges will be accumulate on the body, right? The charges will be accumulate on this body. So this is the way the charges will be accumulate. Now these charges which are accumulated on this one will be, okay, applies the force on this charge because this is also positive charge, positive repulse, there is a force. Now this force of interaction will act between these charges. But here we are not having one charge, and the charges are, we have infinite charges, and these charges also not, okay, at a fixed distance, because if you see this one from the charge capital Q, if you say for example, like we can't take practically, but we can imagine first charge, if you say it is near, second charge here, third charge here. So that means the charge capital Q with a small q, interaction with a small q of the charged body, each charge separate distance are there, separate forces applies. So to calculate the force acting on this capital Q by that charged body, we have to take the, okay, force applied by the each charge onto that capital Q. So it is very difficult because the charged body contains infinite number of charges. So that each charge is calculated, and the addition of all that is very difficult. That's why we are using one of the integration method to solve this one easily. So to solve this one using integration method, so what we are doing is, here I am considering one of the concept called as charge distribution concept. In the case of rod, what way the charges are distributed? In the case of rod, how the charges are distributed? If you see this, the rod contains length L, the charge on that one is small q. So the charges are distributed on that one in terms of linear charge density. Along the length it is distributed, because in the question they did not mention the area, so we should not take any area consideration. So lambda is equal to charge occupied per unit length here. From this I can write what is the charge of that one. The charge on the body is equal to Q is equal to lambda into L. I can write first, we got the how much charge on this rod in terms of linear charge density first. Next, this charge whatever it is there, that is applying the force on the capital Q according to electrostatic force of repulsion. So according to electrostatic force between the two charges, what is the formula? F is equal to, so 1 by 4 pi epsilon naught I am taking as K, that is constant throughout the solution, that's why I am writing as K. K into one charge is small q, second charge is capital Q, okay, K into Q cube by distance between them. Distance between them. The distance between them in this case to take, we can't take that which charges we are going to take, which charge we are going to take. Now I am writing a just general formula as r squared here, but the q, small q, is distributed different, means starting point one value, ending point another value, because the distance is varying. So for that, to solve this one, what you have to do is first consider a small elementary portion here. Consider a small elementary portion of length. A small portion you take. That portion length I am writing as dx. Small length. That length thickness can be, you can choose it according to your convenience, whatever it is. Okay, dx. Now this dx contains the charge. You take it as dq, a small charge. Total charge of the rod is small q, but the small elementary portion which you taken, that charge on that one is equal to dq. The thickness is dx. Now what distance the dx is present, the position of that chosen is equal to x from the capital Q. Now our understanding of the problem is this elementary portion will repulse the capital Q. Now this elementary portion, how much force it is repulsing with the capital Q, that depends on the position of that elementary portion. I can choose this elementary portion here also. You can say I can choose the elementary portion here also at one position. I can choose the elementary portion at the end also. So as the elementary portion position changes, the force of repulsion also changes. That's why it is called variable concept we are calling. That's why what we are doing is, first I am taken the elementary portion at one of the position, that is called x distance of thickness dx and dq. Now I can keep this elementary portion at first position. If you are keeping here, now what is the distance between capital Q and dx? That is small d. Suppose the same elementary portion, if I chosen at the second position, end of the rod, if you chosen that elementary portion, in this case what happened, the distance between the charge and the elementary portion becomes, from here to here is d, charge to the one of the end of the rod is d, length of the rod is l, total d plus l it becomes. So here you need to understand here, if you chosen the elementary portion at near to the charge end, the distance of that charge will becomes d is equal to x. Sorry, x equal to d. The distance of the elementary portion becomes x equal to d. Suppose the same elementary portion, if you taken at the second position, in this case the x1, x2 position, if you choose the elementary portion, in that case the distance between the charge and the elementary portion becomes d plus l. So here the force between the two charges varies from the position d to d plus l. That is the meaning of this. So here variable force is taking place according to the length changes. So here force is changing with respect to length. That's why this, whatever it is, the force which is changing uniformly and constantly with the same value, because this is one of the uniform charge distribution based we are doing the problem. That's why we are using integration method here. So before going to integration, first we need to calculate whatever the elementary portion I chosen, what is the charge of that one. Already we done. The charge of the body Q is equal to, what is the formula we taken, lambda into length of that. Total charge of the rod is equal to linear charge density into total length of that. Now what is the charge of the elementary portion? The charge of the elementary portion is dq. dq is equal to, lambda is called as linear charge distribution, that is constant, that is a linear charge density constant, into length. What is the length which is chosen for elementary portion? Blue color one, the shaded one, very small length, that is dx. For complete length, charge is q. For a small elementary portion, dq charge. What is the length of that one? Dx. So charge dq is equal to lambda into dx. Now apply the formula, force between two charges. Here we are calculating the force between the two charges. F is equal to k into, one charge is capital Q. This is single charge. Second one is small q. The small q we are not taken. Complete body q, we are taking elementary portion. What is the elementary portion charge? That is d. K into capital Q into d by distance. Now what is the distance of that elementary portion? That elementary portion I taken as dx. The distance of that one is I taken as x. So I can write as x square. This is the way you can write the form. Now apply the equation what we derived, that is k into capital Q into, what is dq? Just before we derived, dq is equal to lambda into dx I can write by x square. Now this one we have to integrate. So here I can write as This is dq. Dq means small charge. Small charge means the force is also small force, that is df. So now I can write integral df is equal to, okay, elementary force, elementary charge, elementary force. Integral df is equal to, I can write as, so here before doing integration, constant k is called constant, capital Q is single charge, that is also constant, lambda is called linear charge distribution, that is also constant. All constant I taken out of the integration, and the remaining is I'm writing as dx by x square, like this. So now this is the main part, you have to solve it. If you solve it, our problem will be solved. In this case, whatever the limits, okay, what are the limits here? The x value starting from where? The x value, that is from d value to, okay, x1 to x2 position, right? X1 to x2, x1 value is equal to d, x2 value is equal to d plus n. Up to this, you have to integrate. So first integral dx by x square. What is the formula for this one? Integral dx by x square is equal to nothing but, we can write this one in terms of integral x power minus 2 into dx, I can write. Now this is in the form of integral x power n form. What is the formula for integral x power n? Integral x power n plus 1 by n plus 1 is the formula. So according to that one, x power minus 2 plus 1. Sorry, after integration, we should not write the integration. So after doing this one, x power minus 2 plus 1 by minus 2 plus 1. So after integration, this value, how much you are going to get? This is x power minus 1 by minus 1. So that minus you can keep it in front. So this value you are going to get how much? That x power minus 1 you can make it to the denominator. So that what happens? This becomes integral dx by x square formula. I can write as minus 1 by x. I can write. So here I can put that one. So integral, this is integral df is equal to, formula is f. F is equal to nothing but, I can write as minus 1 by x. I can write this total integration. Lower limit is how much? D. Upper limit is how much? D plus. Along with, we have a constants are there. That is, what is the constant? K, Q, L. Now if you solve this one, we'll get the required answer for this question. Now if you continue this, applying the limits, lower limit and upper limit, what you are going to get? F is equal to K, Q, lambda is constant, and the remaining whatever it is, I can write as a limits as minus 1 by d plus n. Minus of minus becomes 1 by, okay, minus of minus becomes plus, and x value you can put as d. So if you solve this one, what you are going to get? F is equal to K into Q lambda into, if you taken on, and if you write in order 1 by d, okay, minus 1 by d plus L. If you take an LCM of this one, because according to given options to get it, KQ lambda into, that is d plus L minus d by d into d plus L or L plus d. So plus d minus d get cancelled. So after cancellation, what you are going to get? F is equal to, that is nothing but K Q lambda into, that is, you are going to get only L by d into d plus L. So in this case, if you want to write in terms of any terms of charge, I can write this one as F is equal to K into, that is Q into, what is this lambda? Lambda nothing but charge per unit length. So we can write in terms of charge per unit length, we can write that, we can replace later. Charge per unit length into d plus L, I can write, and power we have. So here this cell get cancelled. So I can write as F is equal to K Q square by. So lambda is equal to, I think we have a, okay, lambda is equal to not capital Q, that is small q by L, I think, right? So small q by L. So I can replace here not capital Q, it is small q by L. So I can write, we won't get here square. So one is capital Q, small q by d into d plus L is the solution. Look at this, check it this one once. Okay, in the given options, what are the options is given? You check it that. Okay, you see the options of this one. So what are the options given? The first option is KQ small q, capital Q, K, D, okay, D by D into D plus L. This is the option you are going to take. So the answer for the question is yes. No need to go for any further. You can check the option of this one. So what is the answer you got? You can check it. F is equal to, that is K capital Q small q by D into D plus L. This is the answer. Now we will discuss a small concept, force between system of charges. Up to now we discussed about one charge, right? Now we taken one of the non-uniform shape body which contains the number of charges on it. That charges are taken as Q1, Q2, Q3, Q4, Q5, Q6, so on. Qn. Now this is one of the coordinate system I chosen. Here at the origin I kept one charge. Now what is the force acting on this capital Q due to that number of charges? To calculate this one, we are following a law that is called as vector summation. We are following. Using the vector summation, you can able to calculate the force between the system of charges. That means these are the system of charges which are influencing on the single charge. How much force acting on that single charge due to the system of charges we are explaining. To explain this one first, the force between the two charges depends on magnitude of the charges and distance between the two charges. So that's why first I taken one of the non-uniform shape body. We have in many number of charges are there. Q1 is a charge, okay, and capital Q is another charge. The capital Q and Q1 is separated by certain distance. That distance of that one I can take as Q1. Similarly, the second charge Q2 also, okay, from the second charge Q2 also from the origin, that means capital Q, it is at a distance of this is we can take it, right? The similarly Q3, like this we can take the vector positions of that Q1, Q2, Q3 for the all the charges. I can take it. So these are the positions of the charges from the capital Q. Because different charges having different positions, different charges having different positions. That positions of the each charge we can write like this up to n charges. We taken the body contains n number of charges. Based on this one we taken. This is the way you can take the charge, okay, position of the charges. Now the capital Q, Q1, the Q1 and capital Q interacts each other. There is a force of repulsion along the arrow mark direction. So that force which is between them I can write as, on the first charge is F1, on the second charge I can write as F2, third charge is F3, F4, this is F5, and this is F6, and last one this is number of charges we taken as Fn. So what is the force acting on the capital Q which is at the origin? To explain that one, the force acting on the charge Q is equal to, that is nothing but we are taking as a net force. What is the meaning of net force? Sum of the all the forces, sum of the all the forces. In this case, net force, whenever you are calculating, force is a vector quantity, so whenever you are calculating the net force at a point, okay, sum of the all the forces we are taking, so we are taking the vector sum of the all the forces we have to take, because the angle between the charges, also most important here. So force is also important here. That's why F1 force plus F2 force plus F3 plus F4 plus F5, so on I can write as plus Fn. All are vectors, so we are going to add this one in terms of vector summation. This is nothing but called as vector sum of representation of net force acting on the charge. So whenever the force between the system of charges when taken, the force between the charges always have to take vector sum of all the forces which are acting on the charge. So all the forces you have to add it as a vector summation. If there is an angle between them, according to that one, you have to use the Pythagoras theorem, parallelogram law of vector addition you have to use, or triangle law of vector addition you have to use. According to that one, you have to solve the problem. Now we'll discuss some problems based on these models. Now we will have a theoretical based system of charge formulas will be there. First one, 3 charge system based how to solve the problem, and how the formulas we are going to write, using that how we need to solve different types of models of problems. That is important here. I taken a equilateral triangle. So you know that what is equilateral triangle means? The angle between any two sides is 60 degrees and length is also same. The distance between, okay, the any sides of the length is equal to how much? X I taken. Now I taken three charges here. All are similar charges, Q, Q, Q. All are similar one, positive charges, kept at the three corners of the equilateral triangle. Now, what is the force acting on one of the charge due to remaining charges? This is the system of three charges. Now, there is interaction between these three charges. Now, how the force is acting on one of the charge due to remaining charges, that we need to discuss. If you understand the procedure of solving the problem, that will be easy to solve the problem in further levels in a faster manner. So first, if you come across a case of, I am choosing this is the charge on this, what is the force due to remaining charges I want to calculate. That means question is, what is the force acting on one of the charge due to remaining charges? One of the charge means what is the remaining charges? Remaining two charges. So I chosen what is the force acting on this Q due to remaining two charges. So if you see this one, the first charge is at vertex Q. So the force of attraction between any two charges always acts along the line joining between the two charges only. So here if you see this one, this Q, okay, this Q repel this one in this direction. This is the direction of the repulsion. So I can write this is the direction of the repulsion force, that is F. Now similarly, if you see this one, another charge, this is Q, this is also repel the Q which you taken. Now this repulsion also takes place along the line joining between the two charges only. So this is one charge, this is one charge. So there is a repulsion between these two charges in this direction. That is also I am taking as F. So here you need to understand why we taken both are F only. Is it both are same or different? Here you need to understand force between the two charges always depends on product of the magnitude of the two charges and the square of the distance between. So if you check this one, this is Q, this is Q. Both are having same magnitude and distance is X. So second charge, this is Q, this is also Q. Distance is also X, means both combination of charges are same, distance between the charges also same. So I can write here the force between the, okay, this first charge and this one, that is equal to F is equal to, we can write as 1 by 4 pi epsilon naught, I am writing as a constant K. Both the charges are Q into Q by distance between them is X square. Now similarly third, okay, this is the first, if this is second, if you taken, that is also similar to that one, we can write as same. Otherwise if you want to take as a different, F1 you take it, this you take it as F2. So F1 formula, okay, is equal to K Q by X square, that is equal to, becomes equal to F2. Both are same because magnitude of the Q is same, distance X is also same. So now if you observe this one, this is the most important understanding here. These are the two forces which are acting on this charge. This is the two forces which are acting on this charge, which are supported by certain different angles. Both are not acting on the same direction. One is acting along the x-axis, another one is acting downward direction. So both are supported by certain angle. How much angle it is? According to geometry, we can say that this angle is equal to 60 if we taken. Automatically the outside angle also will becomes equal to 60 according to geometry, opposite angle, right? So these two forces F1, F2 suffered by an angle of 60. Both magnitudes are same. So I can write here simply F1 is equal to F2 is equal to F I am writing. And the angle between these two theta is equal to 60 degrees. So when the two forces are acting on the charge supported by an angle of certain angle, then we can use parallelogram law of vector addition to find the resultant force. What is the direction of the resultant force? Here on this charge, two forces are acting. One is like this, one is like this. So the resultant will be in between the two charges as a Fr. This Fr value we need to find. That Fr formula I can write resultant force equal to, according to parallelogram, I can write as under root of, first one is F1 square plus F2 square plus 2 F1 F2 cos theta is the formula. It's according to parallelogram law of vector addition. Now substitute all the values what you know that. What is the values you know that? The values we know that Fr we need to find. Fr is equal to under root of, what is F1? F1 nothing but F. So F square I can write. This is also F square plus 2 into F into cos 60 degrees, because angle between the two forces is 60. Now if you solve this one, what you are going to get? Resultant force acting on the third charge is equal to Fr is equal to F square plus F square, that is nothing but 2 F square you will get, that is 2 F square plus this is 2 into f into f is f square into cos 60 is nothing but 1 by 2. 2 to get cancelled. How much you are going to get? Fr is equal to nothing but 2f square plus single f square, that is 3f square, root of 3f square. That is 3f square here. Root of 3f square means I can write as root 3f. So the force acting on the third charge due to remaining two charges is equal to how much? Root 3f. So I can write the system is experiencing a force. The resultant force acting on this one, Fr, is equal to root 3 times of f is the answer to the question. So now what is f here? F is nothing but simply I can write as k into q by x square, because combination of charges are same, distance also same. For that, like this, you have to solve the problems in this case of distribution of charges. Now we will discuss system of four charges. System of four charges means we have four charges. They distributed maybe according to their construction. Now what is the force acting on one of the charges due to the system of the charges? So here I taken one of the square frame of length L, and I taken the charges on the four corners of the square of same magnitude, that is small q. Now the question is, what is the force acting on one of the charge? Here I taken the first one, 1. 1 means due to these three charges, okay, what is the force acting on one of the charge? This is on this. How much force is going to act on this charge due to remaining three charges? First question. Second one, at this point, what is the force if you imagine a test charge at this point? Imagine a test charge at this point. Now what is the force on the second point? Like that, the question, two questions we are going to solve. First, to identify this one, you have to understand force between the two charges always acts along the line joining between the two charges. You know that. Now you consider first, this is the one of the charge. I am taking this the charge, which is now this charge repels this first charge, first position charge, okay, with the force of repulsion. What direction? Along the line joining between them. That we can indicating using a vector, because force is vector quantity. This is the direction the force is going to act. So I am taking that force direction like this. This is the way the direction of the force is going to act on this. This magnitude I am taking as how much? That is I am writing as F1 I am taking. Similarly, another charge. This is the another charge you take it, which is at the same distance, because the charge small q, this q, what the distance of this one? L. Similarly, at the same length distance, one more charge is there towards the left hand side. Now this is also applies the force of repulsion on this one in this direction. Okay, this also applies the force of repulsion on this one in this direction. This is the way the force is going to repulse this q at first position in this direction. So this is the way I can take the force of that. So two forces. This force is also I can take it as, you take it as F2 first. Now we have one more charge. Where is another charge? This is the exactly opposite diagonal of this square. So this q also apply the force on this one. Okay, in the along the line joining between them along the straight line only. So that is important. That's why this charge, okay, is repulsing this one in this direction. As you're looking like this, we can say this is the direction the first position charge is going to be repelled. In this direction, it is going to be repelled. This is the way I can take the force of repulsion here. Right? This force I am taking as F3. So there are three forces are acting on this Q at first position. Now find the resultant force of these three. That gives the answer for the question, net force acting on the charge at that position. That is important. First, you need to understand here, if you come across the F1, F2, what is F1? F1 formula I can write as force between this charge and this charge. So formula is K is constant, 1 by 4 pi epsilon naught K, that I am writing as constant K, and first charge is Q, second charge also Q, I can write as Q square, okay, by distance between them. What is the distance from here to here? What is the distance? That is L is the distance between them. L is the distance, because square means all the sides are same, so I can write as L square. This is first equation, right? Similarly, second force, what is F2? What is the F2 formula? F2 is equal to, I can write as K into the charge. This is Q, that is also Q. I can write as same Q square by square of the distance between them. Now, what is the distance between these two? That is also L only. So I can write as L square. So if you observe these two, F1 and F2, both are similar. Charges are same, distance also same. I can write simply F1 is equal to F2 is equal to, you can take it as simply as a F you can, because we have a simple okay, converting uh, can be done using this one. F1 is equal to F2 is equal to F, you can write that. Next, what is the another force? F3. So what is the formula for F3? F3 is equal to, that is K into two charges Q. Okay, this is the Q, this is also Q. Q into Q, Q square, because Q1 Q2 by R square is the formula. Q1 is Q, Q2 also Q, Q1 into Q2, Q into Q is Q square by distance. What is the distance here? To find the distance from here to here is the distance we need. What the distance? So if you observe this one, okay, from this rectangle, this length is L, this is also length L, right? So if you observe this one, I'm making a red color one. This is the one, if you see, this is the way we are getting the one triangle structure here. In this triangle structure, one side length is L, another side length is L. So the diagonal, that means the distance between two charges becomes the diagonal of the square, that becomes hypotenuse of this triangle. So using the Pythagoras theorem, this is L means what you are going to get, this total length is going to get root 2 L using the Pythagoras theorem, right? Because L square plus L square, that is nothing but 2L square, under root of 2L square, nothing but root 2L you will get. So, but okay, the total distance is how much? Root 2L. So, our according to formula, what is the formula here? K into Q square into square of the distance. What is the distance you got? Root 2L whole square. So, if you write in order, what you are going to get? K into Q square by, that is root 2 and the square cancel, that is 2 into 2L square here. So, what is K into Q square by L square? What we defined? We defined K into Q square by L. This is, if you see this one, either F1 or F2. K into Q square by L square, nothing but F1 or F2, that is we called as F. So I can write this one as simply F by 2. So we got the three forces. That means I can write as F1 is equal to F2 is equal to F, I can write, and F3 is equal to F by 2. We got it. Now, what is the, okay, F1, F2? If you see the F1, F2, both are acting in the same direction or different direction. You check it out. If you observe the diagram, this is F2, this is F1, this is F3. Both are, three are not in the same direction. First, what you do is solve it. So, F1, F2 separated by an angle of how much? 90 degrees. And both forces are same. F1 value, F2 value, both are same. That's why the resultant of these two will come exactly along the diagonal. In between, exactly it will come by making an angle 45 degrees here. By making 45 degrees, the resultant will come. So, the diagonal, whatever it is getting, at the same line, we have a third force also. That means the resultant of F1, F2, I am taking as FR1, I am writing first resultant. The first resultant and F3 both are in the same direction. First resultant and F3 both are in the same direction. So I can write simply, okay, net force equal to total force acting on that point is equal to 1 is first resultant force of F1, F2, these two resultant force plus F3. Both are in the same direction. This formula gives the resultant of 4 charges system and the force acting on one of the charge due to remaining. So to find it here, what we need to find FR1. So what is FR1? FR1 is the resultant force between first force and second force. Yes or no? First force is F1, second force is F2, angle between them is 90. So you know the magnitudes, both are same magnitudes, but angle between them is 90 degrees. So when the two forces are having same magnitudes or different magnitudes, if they are separated by a certain angle, you have to use parallelogram law of vector addition. So I can use parallelogram. According to that one, I can write formula F1 square plus F2 square plus 2 F1 F2 cos theta. Now if you substitute in this formula, we are going to get FR1. This is nothing but FR1. First resultant FR1 is equal to under root of, what is F1? Nothing but F. So F square plus F square. Second also same, both are same values. That is 2 into F, nothing but F square. Cos theta value is equal to how much? 90 degrees. Both are separated by 90. So cos 90 value how much? Sin 91. Cos 90 is 0, so total this value will becomes equal to 0. So FR1 is equal to how much you are going to get? That is nothing but root 2 FV. So FR1 you got root 2F. Now our requirement is Fnet. So net force equal to nothing but FR1 plus F3. So now what is FR1? Root 2F plus what is F3? The F3 value already just we calculate in terms of F, that is F by 2. That is F by 2. So if you solve this, what you are going to get? To solve this one, you are going to get how much? So F net is equal to net force acting on the charge is equal to nothing but F if you taken common, that you are going to get root 2 plus 1 by 2. So this is the force acting on the charge, 4 charge system. Whenever you taken the, that means what is the force acting one of the charge due to remaining charges. What is the F formula I can write if you want to write more clearly? F net is equal to what is F? That is simply K into Q square by L square into root 2 plus 1 by 2. This is the way you can able to express the answer for a question. This is theoretical based. Numerical based, we can able to solve it according to the given condition. This is the first question, right? This is the first. Now, what is the second question is given? What is second question? Look at the diagram. In the second question, we have a charge, test charge at the center. Test charge at the center. For that, I am taking the diagram here. A small diagram to understand easily. Okay, this is a way we taken here. And charges are, one charge is Q, second is Q, third is Q, fourth one is Q. We need to find the force acting on this test charge here, that is Q naught, right? So simply first try to understand the diagram of this one. So what based this Q, if you observe here, this Q, okay, this Q repels this one. Just a minute. This Q repels this one in this direction as a looking arrow, right? At the same time, this Q opposite this Q repel this one in this direction. If you see this, both are equal and opposite, right? Equal force, opposite. What is the net force? When both are equal and opposite, net will be 0. Similarly, this charge repel this one in this direction. Similarly, this charge repel this one in this direction. So what is happening here? Whenever you're taking the charges, number of charge system, all charges are, this charge repel this one in this direction, this charge repel this in this direction, all are opposite. So net will be at this point will becomes 0. That means net force equal to becomes 0. All are equal and opposite, net force 0. So here one point you have to note it down. Whenever you taken the system of distribution of charges at the common center, if you take any system of charges at common center, the force acting on at the common center always 0 if there is any charges present. Okay, if there is no charge, if you want to explain the force, you have to imagine a test charge at that place. Based on that one, you can able to explain. So the answer for the first question is F into root 2 plus 1 by 2. Second question answer is what is the net force at this point is equal to net force at this point equal to 0. This is the answer for the question. Next question, we'll go to the one of the numerical based question, advanced level questions. Sometimes they'll ask the numerical based, and mains also they'll ask the numerical based questions. One just problem in it today. They given one of the Bohr's theory question, a Bohr's theory of hydrogen atom. In a hydrogen atom, electron is moving in a circular orbit. Electron is revolving in the circular orbit of radius how much? 0.53. So radius of the orbit is given 0.53 angstroms. So that is nothing but 0.53 into 10 power minus 10 meters. 1 angstrom is equal. Now speed of the electrons in the Bohr's orbit, okay, speed of the electron means that electron which is revolving in the orbit, the speed of this one is, if you say, as v. This v is equal to how much they given, 1 by n into 69 times the speed of the light is given. Speed of the light we are indicating the c. The c value is equal to nothing but 3 into 10 power of 8 meter per second is the speed of the light value. So what they're asking here, find the value of n. N is equal to how much? Numerical based question. So in this case, our concept is simple here. Electron is negative charge and it is revolving around the center, that is called positive hydrogen atom, okay, orbit, positive nucleus. So plus and minus both are having interaction. That interaction due to charge at the nucleus and charge of the electron, that, okay, interaction nothing but force. Due to that force, what is happens, it is going to revolve. Again, you have to understand here, while it is revolving, so the force of attraction between the, okay, nucleus and the electron will provide the necessary centripetal force for the rotation. So here F is equal to, I can write as K into, one is charge of the electron, one is charge of the nucleus by, and okay, distance between them is square of the distance between them, r square, and this is 1, and that force is providing necessary centripetal force, that we can write as mv square by r, because the question is they are asking velocities, so this v they are asking, so we can write it in that. So in this case, this force only provides the necessary centripetal force, so force due to electrostatics is equal to nothing but, we can write as centripetal force. Using this one, we can able to solve the problem now. What is okay, electrostatic force? That is nothing but K, 1 by 4 pi epsilon naught. Both the charges are, okay, that is Q positive charge, electron charge, both are I am taking as in terms of charge, that is E square, because both are equal magnitude, opposite nature, one is positive, one is negative, so both are I am taking as electric, okay, electron charge only. E square by r square is equal to mv square by r. Now calculate here. So what is requirement here? R, 1 r get cancelled, anything other, no, we can't cancel anything, so v square is equal to, I can write as, that is nothing but 1 by 4 pi epsilon naught E square by m, I can write, and also we have a r. Now substitute the, so our requirement is v, so v is equal to nothing but, if we take in v, that becomes square root, that is whole power 1 by 2, nothing, that is nothing but root. So v is equal to, substitute 1 by 4 pi epsilon naught value while solving, you can write as 9 into 10 power 9 into charge of the electron is 1.6 into 10 power minus 19 coulomb, that is we have a whole square is there, by m is called mass of the electron, electron is revolving, mass of the electron is 9.1 into, that is I am taking as nearly 9 into 10 power minus 31, I am taking rounding off to solve the problem faster, into radius. What is the radius here? Radius is equal to radius of the orbit is 0.53, that is nothing but I can write as 53 into 10 power minus 12, I can write, and the whole power, anyway we have 1 by. Now if you solve this one, how much you are going to get here? 9 we can cancel here, and okay, and we can cancel here 10 power 9 into 16 into 10 power minus 20 whole square by, that is we can write as 53 into 10 power minus 31 minus 12, that becomes minus 43 whole power 1 by 2. Now if you solve this value, how much you will get? That is, here we can write as 10 power 9, 10 power 9, okay, root value will do it in the last, 10 power 9 into 16 whole square, that is nothing but 256, we can write 256 into 10 power 20 square means, that is 40 minus 40 by, this is 53 into 10 power minus 43. This 10 power minus 43, what I am doing is I am taking to the numerator. This 10 power 43 I am taking to the numerator, that becomes plus 40. 10 power plus 43. So if you solve it, what you are going to get? This is minus 43 minus 40 plus. This is becomes 3 3 means what is the remaining? Already we have 256 into 10 power 9 plus 3, that is becomes 12 by 53. So this is the value you are going to get whole power 1 by 2. That is anyway common. Here also whole power 1 by 2. We solve this one 53, 50. Okay, 5 times, that is 250, and 265 you get, and less than 5. So this value, if you calculate rounding off, I will write directly here. This value rounding off, we are going to get 2.16 into 10 power 6 meter per second. You calculate this value separately and you can check it out, because due to the time function, we are writing directly here. Yes. Now, answer is given in terms of speed of the light. So the function is given speed of the light. So that's why what you do is compare this one. If you compare this one with the C by V value, if you compare this one, the C value is equal to 3 into 10 power of 8, and that V value is equal to how much? 2.16 into 10 power 6. Now this value, if you calculate this, we are going to get nearly, okay, uh, that is nothing but the fraction. This is in terms of C by 138. Okay, nearly you are going to get V value is equal to, that means this is C by, if you calculate, that I'm writing as this is equal to V is equal to, I can write as C by nearly 138, nearly you are going to get this value. So 138 means 68 into how much? If you multiply, you will get that one. That is nothing but, if you write in the form of that one, C by, okay, that I can write as 2 into 69. 69 to the 138 you get. That is, okay, this form we can write. Now compare these two. If you compare this one, this is in the form of C by n into 69 is given. The speed is given as n into 69. So in the place of n, what we have here, we have a 2. So answer for our question is n value is equal to 2. So the numerical questions can be solved using this method. That is n is equal to 2. So the question answer for this question is 2. In the next class also, next video also, we are going to do the electrostatic problems on this one. On the basing on force, some models will do. Then after we go for electrical concept. Till then, you just practice the, okay, the problems which are we explained, and just note down the things which is required for us.